Hello everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please give it a shot, pause the video, and we will do it. Okay, we're given a function there. C depends on B and D. Okay. Which of the following equations correctly gives the displacement, D, well that says D, right? D equals the other variables. So this is just solving for variables. Sometimes it's called a literal. You have to solve for D, right? So you have to pretend all the other things are numbers. So there's probably a fast way to do it, but you could just cross multiply. Cube root of D times C is 4B. We're going after this thing. So the cube root of D is 4B over C. So in order to, this is really messy, I'm sorry, cube root of D. And to make the D by itself, you cube both sides to get D is equal to, and this point you stop. Because then you just look at the answer. You don't actually have to write this, you can just look. And then it looks like it's this one after you double check and make, after saying, you give it a little proofread. Then, if you had time, you would just confirm to see if this makes sense. It does, because the cube has to cube everybody, including the 4B and the C, not this one, because the C is not getting cubed. Poor C. The B is not getting cubed. Poor B. And here it's the reciprocal, so that's a wrong. So, seems like a very straightforward problem. You just can't be intimidated by letters. You just treat the letters as if they're numbers, and you solve for the variable. Always remembering to first isolate the variable term, which is this thing. You want to isolate this thing first. See? And then, after you've isolated this, then you deal with unwrapping the cube root and dealing with the cube root.
Okay.
So what do you have to say, Seth?
The takeaway from this problem.
Takeaway, go ahead.
Is a very quick, direct rule is available. It's very good to learn this rule, and I wrote it up here. The rule is that when you have, this expression, something A is equal to a fraction, B over C. When, generally, if A or C are 0, it's not true. But if both A and C are non-zero, this equation is equivalent to this equation. And you get to the rule is that you just do the switcheroo.
Yep.
Between the the single expression on the left and the expression in the denominator on the right. So I think a takeaway when you study for the SAT and you see problems like this, it's really a good idea to, after you review or learn the derivation and the calculation using cross multiply, to then learn that there's a shortcut. The consequence of cross multiplying is this switcheroo rule, which enables you to deal with simplifications much more quickly, and also it leads to greater, less chance of making a mistake, because the more calculations you write out, the more chance there is for a mistake.
Well, okay, fine. It does it quickly. I would not say it does it much quickly. Maybe as a percent, yes, but as an actual amount of time, it doesn't take. Maybe it takes 3 seconds more to multiply.
3 seconds is a lot.
No, it's not. It's not. 3, maybe 8, maybe 12, maybe 15 seconds is a lot, but 3 seconds is not a lot. The
Okay,
danger.
we're offering a range of approaches.
Yes, we are.
This is,
Exactly.
my one of my suggestions. So our audience could either take it or leave it.
Right. And I would argue that I don't like to memorize formulas. I don't like to memorize relationships when deriving them from scratch is almost as easy as remembering them, because if you have too many things in your head, you may get confused as, oh, what is that one? What is that one? But yes, if you
Well,
do it
the thing is
enough,
that I disagree with that. I disagree with that. Part of becoming skilled,
yeah,
becoming skilled consists of consists of having ready to use a lot of rules.
okay,
The behind that is also knowing where the rules come from,
yeah,
but then being able to just pick them out and use them
right,
is what constitutes fluency and skill.
yeah, yeah, okay,
So I think it's a misconception that math is easy uh, and doesn't require memorization because you could derive everything. The problem is that there's too that deriving everything from scratch uh, it distracts you from the interesting overall problem you're trying to solve.
I mean, I don't know. It is an argument for doing every problem the same way, even if it is slightly
No,
longer.
thing is, I'm speaking point of view of I would say professional mathematician.
Right, right, right,
Yeah,
right, right, right. Yeah, yeah,
and it's like being a musician. A musician, musical skill means that you have a lot of many, many, many techniques
yeah.
are, are learned so that they could be applied unconsciously.
Right, right, right. Well, it's like cooking too. Like a professional cook, if I'm sure if they're making something, they've measured a teaspoon of salt or just the right amount of spice every time. They don't sit there with they probably don't take there with a quarter teaspoon of a little quarter teaspoon of garlic powder. They know exactly, just can pick it up and just do it. Uh, yeah, I mean anyone who gets skilled knows what to do very quickly. Um,
And then
so
I think indeed I might say is that SAT math questions measure they measure skill and fluency in the subject of math that you were taught.
right,
In addition to conceptual knowledge.
yeah, yeah. For example, I sort of use that here with enough seeing this type of problem. You don't really have to waste your time reading this thing. You don't have to. You just
Exactly.
look. You
Yes.
just look at this thing, and then one day, oh, this is what they call the little problem. I don't care less about higher capsize screening value suggests the sailboat is more stable. That's a total waste of time to read. So that way, you're using the skills you're suggesting, and enough fluency in this type of question means you don't have to waste your time reading this thing. You just solve for D. Period. Out of here.
I agree. Yes.
Yeah, yeah,
I when I
yeah,
looked at the problem, I skimmed
yeah,
the was it 5 lines of
yeah. I know,
English,
I know, I know, I know. And did you
and
notice?
I gained some assurance that I didn't have to pay attention
Yeah,
to
yeah,
the
yeah.
interpretation
Right,
or the origin or the physics
right. So I.
that the that
That's right.
the equation that the formula expresses, that this problem is simply
Yeah,
solve for D in terms of the other variables.
right. And if you go back to
And
old
then
video,
I also got a clue that that's what they were asking for, because the choices
Right, exactly.
all have the form
Of course.
D
Yeah,
equals
right.
some
Yeah. Well, I
expression.
noted that when you go back to the video. I noted that, right? I noted that. And usually when we do these things, I usually read the whole question. If you go back to the beginning of the video, I didn't read this. I didn't waste our time reading this thing.
Yeah.
Yeah. So that's that. So yeah. So we all. Yeah. So then always look for shortcuts because time is of time is an issue on these tests.
Ah,
Okay.
okay.
So let's see how they did it. Clear all drawings. Stop this. I think it's this one. Let's see. Okay. Nice work. That's good. Step-by-step solution. Probably not a lot of steps. 4 steps. That's pretty reasonable. Let's start by getting the D term out of the denominator. Ooh, they're multiplying both sides by D. They're multiplying both sides by the D term, right? Because they have to get the D term by itself. So they're multiplying both sides by D term. That's even longer than cross multiplying. Because in cross multiplying, you don't have to write the cube root of D twice and cross it off. I don't know how many people would. Again, there's this difference, noted difference between how they do the problem and how you probably should do it on the SAT, which is to save a little writing. You really don't have to. Cross multiplying is fast in that. Then you divide both sides by C, right? And then you have to undo the cube root, so you have to cube both sides, and that eventually gives you the answer. So this is even longer than cross multiplying. So
yeah.
Okay, what are we going to say? Not much than we already said before, right? Not much more to say, right? Right? Okay, so this is Seth Chaiken. He is a PhD in math from MIT, and he is a professor emeritus at SUNY Albany, teaching for a load of years in the computer science department.
35.
35 years. Wow. I'm Seth's brother. I have a PhD in mechanical engineering from Columbia University, and we are here to hopefully offer different approaches and how to approach doing actual SAT math questions. These come from Khan Academy. Khan Academy offers a wonderful practice questions. They offer like 600 to 700 practice questions for both the digital and the non-digital SAT, depending on which one you're going to take. These are great practice questions. They're sanctioned by the SAT people, but after you're done with these, go actually take some practice SAT tests that are offered by the College Board. And we try to meet every day. We do one question a day. Now we're going through the Khan Academy questions on the digital side. Please like, dislike, and give us comments on our YouTube videos. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Seth is trying. You can see that devilish smile. See that in his eyes? You see that devilish smile? Seth scheming to do something. I see a little.
I'm just messing with the Zoom
I
window.
see a little thing up there. I see a little thing that he may have been playing with. Anyway, so we're done. Okay, everyone. Have a great day. Take care. Bye-bye.